How are you guys? Welcome back to my YouTube channel. We're still under strength of material N6. I've given the following. Says the question, the steel bolt shown in figure. We've given the shown in figure 9.9.6 is 600 millimeter long. The bolt has a diameter of 10 millimeter for half its length and diameter of 20 for the rest of its length, right? Then there it says calculate the extension of the bolt and the total strain when the bolt is placed under a tensile load of 10 kilonewtons. Young modulus of elasticity is 200 gigapascal. We've given this. As you can see, guys, check, we've given part 2 and part 1. So that means this is a series. It's a series. So if we are given series, you must understand that F1 must be equals to F2. Remember from the series bar, right? So that is what you're supposed to remember. Then we are given, what you must know again is that total extension, remember this is a series, total extension must be extension 1 for the section 1 plus section 2. All right. Also, the total strain must be strain of the first section plus strain of the second section. These are the three things you're supposed to know so far. All right, if you have given series bars. All right, this is what we have. So we should calculate the total extension, and they want this. All right, so how can you go about this? All right, so let's check our thing. We should calculate total extension. Total extension must be extension 1 plus extension 2. So we have to have extension 1. Extension 1 is given by force multiplied by length divided by area multiplied by Young modulus of elasticity. That is what we have there. Also, extension 2 is the same formula. Will be force length 1 area 1 multiplied by the length 1 divided by area 2 length 2 multiplied by Young modulus of elasticity. Since it's made up of the same material, they will have the same Young modulus of elasticity. All right, it's fine. This is what we have extra there. So extension 1, we have given force there is 10 kilonewton times 10 to the power of 3. It's kilonewton, isn't it? Multiplied by the length of the first section. What is the length of the first section? Is this one. First section, this here, this is the first section, is 300 there. 300 is the same as 0,3 multiplied by 0,3. We have even the length there, which is, we have given everything for the first portion. So okay, oh, that is the diameter. So I wanted to, that is the length that we multiply. The diameter is 10 there. So the area we know, divide this, the area is pi over 4 multiplied by diameter squared, right? So but we've given 10 there, so it's the same as 0,01. Then we square that, we multiply by Young modulus of elasticity. It was 200 gigapascal times 10 to the power of positive 9. All right, therefore extension 1 will be equals to, if we punch that, we'll have 190,985 times 10 to the power of minus 6 meter. All right, that is the length is measured in meter. So let's find extension 2. The force is the same. All right, times 10 to the power of 3 What about the length now? The length also is 300, okay? Even the length is the same. So multiply by 0.3, divide this by the area. We know is pi over 4. Then the diameter for the second portion here is 20. Then it's the same as 0.02. Then we square this, we multiply by here modulus of elasticity, 200 times 10 to the power of positive 9. Therefore the extension 2 will be equals to what? This will be 47, 747 times 10 to the power of minus 6. This is what it's in meter. All right, we have this now. So we have our total extension. We have the extension, but we know that the total extension we said is that. So the total extension will be equals to x1 plus x2. We have x1 190,985 times 10 to the power of minus 6 plus extension 2 is 47,747 times 10 to the power of minus 6. Therefore, our total extension will be equals to 232 times 10 to the power of minus 6. So here it's in mid. This is our total extension. Alright, so we have got that, we have answered that, but they say also the total strain. We know that the total strain is given by this. Alright, so we can get the total strain. Total strain might be equal to strain 1 plus strain 2. Alright, but we know that the strain is given by 1 over 2 multiplied by force multiplied by x. This is the formula for strain. So since we have the first part, we will be 1 over 2 f1 x1 plus second part would be 1 over 2 multiplied by f2 multiplied by x2. Alright, so if you can check, 1 over 2 is the same. Obviously the force, remember the force we said will be the same. F1 will be the same as F2 because it's in series. I can take that as a common factor. It will be the same anyways. You can just call it F because it will be the same. You can just make it to be X anyway. 1 over 2 multiplied by force. Take as common factor, I'll be left with x1 plus x2. But anyways, x1 plus x2, we said this is what? It's the same as total strain. That is our total, sorry, it's a total extension. But that we know that is a total what? Extension. So we'll substitute our total extension. The force is still 10 times 10 to the power of what? Of positive 3. The total strain, that is what we're supposed to do. X1 plus x2 is this one. Here it's our total strain. So which is that value there, 238,732 times 10 to the power of minus 6 there. Alright. Times 10 to the power of minus 6. So this will simply equals to what? This will simply equals to what? 1,194 joules. Obviously, its strain is measured in joules. That is our total strain. This is our total strain. So thank you for watching. May you kindly subscribe to my YouTube channel and become the part of the family. If you have not subscribed, feel free to like and comment. In the next coming session, I'm thinking of doing tin cylinders. I will do tin cylinders, so just subscribe them. I will do some tin cylinders them.